Okay guys, this is with your triangle congruence worksheet. Today we're going to be talking about the difference between things being similar and things being congruent. So whenever they are similar, we have these three theorems that we can use. So with this, remember, similar just means that they're going to have a scale factor, or it's going to be dilated of some sort. Scale factor of some sort, could be 1, but it could also be 2, 3, whatever. And then whenever they are congruent just means equal, all the exact same, would have to have one of these purple combinations, with the scale factor being 1 of all that. And so what I would encourage you to do is mark your figure, and everything that you mark on your figure you will write down as a statement. Okay, so for number 1, and I would encourage you also just pause whenever you need to and maybe try some on your own as I'm describing this. Okay, so the first thing I see here is I've got vertical angles. Boom. So since these are angles, I'm going to write that on one of the angle congruences. So again, make sure that C is in the middle whenever you're describing this. I'm not just going to say angle C because that could mean either one of these. So it says if you're tracing it, C is the vertex, so it needs to be in the middle. So this would be BCA or ACB, either one. I'm going to go with angle ACB equals angle DCE. Why? Because they're vertical. The next one here, I see this sign. Okay. This slash here means that they're the same length, so I can say side BC is congruent to side CE. So since this is not an angle, I'm going to write it down here where there's no angle sign. So BC is equal to CE. Now this last one here, some of you guys are like, well, I see these markings. All right, this does not mean that DE is equal to BA. This is saying that these are parallel. So if you guys remember what we did with parallel lines, we could trace them and form the Z. So boom, 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 to create two angles that are equal. So I could say this angle is equal to this one. The ones formed by the Z. So I could say angle D is equal to angle A. Okay, you could also go the other direction if you wanted to. So if I do something like this, I could start here and create a Z this way to make this angle equal to this one. Okay, I know it seems like a lot. You don't have to draw the Z's as long as you can visually kind of see them. All right, so then this one, I'm going to look for whatever combination I have here. So this is, remember, we're not skipping. I'm not going to use the arrow. You never use the arrow with your statements because they're not equal. So I'm going to go, I see angle, angle, side with angle, angle, side. So these are congruent. Anything that's congruent is also similar at the same time. And then ABC, try to get it the same order. 2, nothing, 1 would go with 2, nothing, 1, DEC. All right, and number 2 here, first thing I'm going to mark, I see a shared side. So no matter what, mark vertical angles, shared sides, and alternate interior angles. 3 things that we can mark. So now to say this, since it is a shared side, I'm going to say MO equals MO. And you could put this on the top part. That just means that MO is in common between both triangles. MO is the same length in my left triangle as what it is in the right triangle. Looks a little weird. Okay. Next thing I see is I see these guys. So I can say ML is equal to MN. Then I've got this bottom guy. I've got these angles down here. Again, not just angle O. MOL equals MON. And since that's an angle reference, I'm putting it with the angles. All right. Now I'm trying to figure out my combination. I can't mark anything else. Some people have the tendency of marking these top angles or these ones. It's not vertical. All right, they're not alternate interior, so I cannot mark them. So now I'm going through trying to do side, start here, side, angle. Well, I skip around for the side, so I can't use side, angle, side. No skipping. No other ones. Use two S's. Oh, but I have a right angle. This is my one where it's a hypotenuse matched with a leg because of the right angle. So these are congruent. HL is for the congruent by HL. LMO is equal to NMO. Okay. Maybe pause it on this one for number 3. Try that one on your own. Okay. And so the first thing I see is vertical angles. Again, you can do these in different orders. Like whatever you have here can be in different orders. I'm going to go, whatever I mark though, I normally write down first. So WZV, I think. WZV equals XZY. All right. I've got WZ equals ZY. And then I have this last angle here. I've got angle W. Equals angle Y. So now it looks like I've got angle, side, angle with angle, side, angle. So they are congruent and similar by angle, side, angle. VWZ. VWZ is congruent to X, Y, Z. Difference here, this is talking about the triangle. These up here are just talking about the angles. Okay. Number 4, go ahead and hit pause and try that one. Hopefully with these right triangles, you think of doing the Pythagorean theorem. If you solve that, you get X equals 8, I believe. So 8 would go here. This would become a 3. So now, these do not have a scale factor of 1. But now I can try to figure out if they are similar or not. So I can find my scale factors. So this would be, I could go side, angle, side here with the 6 and the 8, the 3 and the 4. Or I could do side, side, side. You kind of have the freedom. But I would go big to small. I'm going to go side, angle, side. So 6 goes with 3. So I'm going to show in my flow chart 6 over 3, my scale factor. Angle A is equal to angle Y. And then 8 goes to 4. Okay, so these are not congruent because I have a different scale factor. These would be similar by side, angle, side. Then CBA would be similar to triangle X. Nope, ZXY. All right. Okay, for 5, I'll do 5 and 6 yet. Okay, you can pause, try it on your own. Feel free. First thing I see are these parallel lines, which means I can mark a Z only with that connect the parallel lines. So I cannot go this way because these X, Y, and WZ are not parallel. But I can mark this angle and this angle because of the parallel lines. So I have angle XWY equals angle ZYW I see a shared side. So I can see WY equals WY. I also have these two guys being equal, WZ and XY. Now, I cannot do a Z this way because they're not parallel. Parallel does not mean congruent. So now when I'm trying to do this, I cannot count this as a side. That's an arrow, not a slash. They are parallel, not congruent. So when I go through my triangles here, so I got this top right one. If I start with the side, it would be like side. Well, I can't do angle because that's skipping this one. Let's go the other way. Side, side, angle. That's not a thing. Or angle, side, side. That's not a thing. So this is neither. So then I'm done. All right, this last one. I've got some parallels. I've got two sets of parallels, so now I can do two sets of alternate interiors. So I've got this, boom, boom, boom. I can say this angle here is congruent to this angle down here. But since I have two sets, I can actually go the other direction as well. I'll use blue. So I can go here. I'll start with the T. Boom. It actually makes kind of like an N here, going back and forth. So then I can say that this angle is equal to this one. And I have my shared side. Okay, two angle congruences and one shared side. So SQ equals SQ. All right, I've got angle TQS is congruent to angle RSQ. I've also got TSQ is equal to angle SQR. Now I'm looking, I've got, can't use the arrows, angle, side, angle, staying in one triangle, angle, side, angle with angle, side, angle on the other one. TQS, going nothing, 1, 2, would go nothing, 1, 2, RSQ.